I'm Stefan, a developer advocate with Silitz, and so we're the company behind the open source vector database Milvus, which we donated to the Linux Foundation in 2019, I believe. So as a developer advocate, really love connecting with users, hearing like what you're building, helping you solve technical challenges. So do feel free to scan my QR code, connect with me on LinkedIn, and join the Milvus community as well, the Discord. Okay, so I'm not sure how much people know about vector databases and embeddings already, so I'm just going to very quickly start from the beginning. So I'm sure most people have heard of these new types of web searches enabled by generative AI. And so one really one you might probably heard of is perplexity.ai. So you type in a question, natural language, it goes off, draws from its vector database, probably has other types of databases, but it draws in all those sources and then somehow sort of synthesizes that into like a natural language response. And so I think this is one of like the killer applications of generative AI, and something that is already starting to really explode. And so why is this like a difficult problem? So this depends on something called semantic search. And so semantic search is a term we use like in contrast to lexical search. So whereas like lexical search is based entirely on keywords, semantic search is based on deep learning embeddings. And another way I like to put it is, so lexical search is based on the frequency of keywords within documents and across documents, whereas semantic search, is connected to the statistics of words in relation to other words, like the company that words keep. So sort of capture two different parts of the meaning. But semantic search is difficult because it needs to be able to sort of like connect related items that from a lexical search point of view are just totally unrelated keywords. So, rising dough and proofing bread, we know as people that those mean the same thing, but if we just view them as discrete keywords, how will like a machine learning algorithm know that? So this semantic search is becoming more and more important relative to lexical search because 90%, it's estimated that 90% of newly generated data by the end of the year will be unstructured data. And so that includes things like images, video, audio, graphs, molecules, point clouds, 3D meshes. And so to be able to search that, I mean, obviously it doesn't have any sort of keywords as such. We need to use these deep learning methods to perform semantic search. So the solution, of course, is enabled by deep learning. And so what we do is we take our knowledge base, we put our items through a deep neural network to produce these output vectors. And then these vectors, it turns out, as you go deeper down the neural network, like deeper into the layers, it's learning a representation that's higher and higher level. So by the time you get to the end of the deep neural network, it has like a very sort of high level representation that captures the semantics. And if we sort of compare two similar inputs in this vector space, points that are close, it turns out semantically similar. So here's an example. This is like with a multimodal embedding. We might have like a sentence, a dog has walked. We put that through our neural network, we get the green point. Then we have like an image of a girl walking a dog. Then that through our image encoder gets mapped to a very similar point. So because they're semantically related. And yep, okay. So, but what exactly is the challenge there? Well, this is a different type of search. So we have to work out how do we index and search a very high dimensional vector space that might have thousands of dimensions. And then how do we scale it? It might have 1 million vectors, it might have 100 million. 1 billion, even up to 1 trillion vectors. So how can we search that space and do it efficiently, still have really acceptable, like, I don't know, sub 100 millisecond response types? And how can we do that for different types of data, different modalities? So this is where a vector database comes in. And so Milvus is the leading open source vector database with a focus on scalability. It scales to literally the billions of vectors, and so when I say leading, that's sort of by a few indicators. We're using the number of Docker pools, as well as like other sort of web traffic, PyPy statistics to like sort of quantify that it's the most popular open source vector database. Also used by many big companies from NVIDIA, Microsoft, eBay, etc. And because it's open source, it has really good integrations with the whole ecosystem of generative AI tooling, both open and closed source. So maybe just like a quick word about like why open source. The first thing is flexibility. So with this system, you can deploy it on premise. You have all of the like understanding of how it's going on behind the scenes, a control over how it's deployed. You can build custom features in if you need to. Secondly is innovation. So it's something that, so open source software, because everyone can contribute, just seems to have a much faster rate of innovation. And I guess connected to that is community. So these open source projects develop like communities around them. And we're very fortunate to have a large community on Discord, GitHub, LinkedIn, Reddit, etc. So maybe like a reverse question, like why not just use a relational database or a graph database? And in like a nutshell, it's because you have to really design your database from the bottom up for vector search for it to scale. So you can't really just sort of like tack on a vector index to a traditional database. So Milvus comes in 3 different deployment options. You've got Lite, works in a notebook on your computer. A standalone version runs in a Docker image. You can scale up to tens, hundreds of millions of vectors. You can serve web traffic, develop more substantive prototypes on your local machine. And then we have the fully distributed version, Milvus cluster. So deployed with Kubernetes is like a sort of a complex system of different types of nodes fulfilling different types of functions, and scales to, I actually heard yesterday, there's a deployment out there with 1 trillion vectors. So I think that's pretty impressive. So that's Milvus and vector databases in a nutshell. Now, let me very quickly take you over how you actually use it. So I've got this getting started notebook here. I'll paste it into the chat after I've finished giving this little presentation. So Milvus has like a number of SDKs for different languages. I think most commonly people will be using Python for prototyping, and the library is called PyMilvus. So you just have to start off by pip installing PyMilvus. This option model, that's sort of like an experimental feature at the moment where we'll sort of have default embedding models for you. So you don't need to use another library like Hugging Face sentence transformers. Okay, so we've installed the library, we import it, we then create this Milvus client object. And so this is what actually establishes a connection to the vector database. And similar to how we create a table in a relational database, analogous to that is what we call a collection in Milvus. So we create a collection. We also tell it the dimensionality of our vector embeddings in advance. And then we have to have a model to do the embedding. So in our case, we'll use the default embedding model from PyMilvus, but you can use anything from Hugging Face's sentence transformers to OpenAI or Anthropic. And here's an example. So here's an example of embedding some documents and then storing them in the vector database in preparation for doing a similarity search. So here are 3 strings that we want to search. Maybe I'll just make it a bit bigger. So we use this embedding function to encode these into these 768 dimensional vectors. And then we create a little sort of data structure that we insert into the vector database. And it has, so this is like a list of rows, but we call rows entities in Milvus. And these are the fields. So each entity will have an ID, which is the primary key. It will have the vector embedding itself. It will have the corresponding text to connect the text, the vector back to the text after we've done the similarity search. We're going to put an extra metadata field subject. So we can include additional fields, just like a relational database, and then do filtering on that. So sort of like a where clause in SQL. So then we just call client.insert, and that inserts these 3 entries into our vector database. So once we've done that, search is very simple. We embed our search string, and then we call client.search, and we pass it the query vector. So we have to give it the vector embedding. We can't just give it the string. It works sort of purely with vectors. And then we can tell it, find the closest 2 matches, for example, and then return these fields. And so when you've done that, it calculates the distance in a very efficient way between the query vector and all of the vectors that you've embedded, and gives you back the 2 top matches with the corresponding fields. If we want to do metadata searching, you just include a little statement like this, subject equals biology, for example. That's sort of, yeah, I mean, that's in a nutshell, like the really essentials of Milvus and how to use it. There are other operations too, of course, deleting entities, updating entities. Just check out the Milvus IO docs, really helpful there. Now that we've got this file on disk, we can then reload it. So here's an example of doing that and just showing that works. So one last thing before I hand it back. We're working with the Milvus Lite deployment. If you wanted to scale up, you could open up Milvus standalone on a Docker image on your local machine, and then you would just replace the file name with this URL and give it like an access token too. And then all of the API is the same, but now you're working with like a server. And similarly for Milvus cluster. So let me just take you to the docs, and then I'll hand it back. So I really encourage you to check out the docs. So what I was doing was essentially taking you through the quick start. We've got all the different guides here on the different deployment options, different SDKs, as well as a lot more detail on all of these concepts underlying it. And then you might find it useful too to look at these tutorials, which go through how to actually build specific things with Milvus, like RAG, full text search, so you can do lexical search in Milvus as well, graph RAG, all sorts of interesting stuff. So hopefully that sort of give you a good grounding in Milvus. And if you have like any questions, we've got a really good community. Check out our Discord. You can go to the community page, follow a link to the Discord, and we run one-on-one office hours as well. So thanks everyone, and hope to see you there.
All right, everyone, welcome. My name is Sujee Maniyam. I'm a DevRel engineer. I work with AI Alliance. By the way, here's a little screenshot if you want to take or note the URL. This is the link to the presentation. Don't worry, we will post all the links, all the code, everything will be sent out to you. So you don't have to scribble notes. Just take a screenshot if you want, and then you can go to the URL to find out more. I am going to talk about using RAG application with DataPrepKit, Milvus, and Granite. Quick background on me. My background is AI, data engineering, and these days I'm focusing more on Gen AI. I work with, like I said, I'm working with the AI Alliance on the DataPrepKit project. I'm keeping an eye on the chat window. So if you have any questions, so what I like to do is I like to keep you on mute just so the line is clear as much as we can. If you have any questions, please post on the chat window. We will, I will keep an eye on this. Yeah. So, so Dave's, we will, I'll keep an eye on the chat window. So this way the line is clear. Okay. So let's start with RAG, why we need it. Yeah. So at this point, we all use large language models like ChatGPT, right? They are very popular. They are trained on huge amount of data. And this data is publicly available data, right? So it could be, Wikipedia, tweets, news articles. So they gather all this public available data and then train the model. And that's how the model has so much knowledge built into them, right? So when you talk about data, it could be code, it could be documents, anything you can imagine. So these are all fed to the LLM. So that's why, like for example, if you go to any LLM, say ChatGPT and alike, you can ask any questions, right? You can say, write me a haiku about cats, right? And then it'll write you a haiku. You can also say, write me Python code to do something, and it'll do it for you. Why? Because they've been trained on data like this, right? So they can be creative like this, or they can answer questions like, write me code, proofread my essay, things like that. However, if you ask anything about our private data, like for example, if let's say I have a bunch of documents inside the company, and some of them are financial documents with say sales projections. And if I ask, okay, what's our sales projection for next year? The LLM doesn't know it. Why? Because they were not trained on the data, right? So the private data. So now the point is, like, without having to train an LLM in our own data, which is a very expensive proposition, right? I mean, you can imagine training LLMs are expensive. Even though, if you follow the news, DeepSeek, right, last couple of weeks, they actually made a lot of waves announcing they can train LLMs much cheaper. But still, I mean, right, still, it takes a few million to train an LLM, right? And this is not something, we want to do because it takes a lot of expertise as well. So how can we use an LLM? Because they already have a lot of knowledge already baked in. How can we use their knowledge, but use it to focus on our own private data? And that's where the RAG comes in, right? So for example, if you look at this diagram here, so let's say I have a bunch of documents or code, what have you. We want to supply
Sujee,
this.
Can you make your screen full screen again? If somebody bumped you out of the view. Yeah, thank you.
All right. Yeah, please let me know. I will, do this again here. Yeah. All right. Again, thank you everyone for your patience. Yeah. It's okay. So okay. Hopefully that's good. So question is, I have a bunch of data, internal data. How do I supply this to LLM and ask questions? All right. So for example, let's say I supply a bunch of documents, and I can say, all right, second, right? So ask questions. So the document we are supplying is called context. So we actually saying, okay, hey, take a look at these documents, read through them, and answer the questions for me. And the LLM, remember, LLMs already have a lot of knowledge built in, so they are very capable of going through these documents and answering the questions. Yeah, pretty good. So this is what we want. So this is kind of essentially what RAG is, right? We are leveraging LLM's knowledge to basically answer our own data. But there are some challenges with this approach. So one of them is, so imagine I have lots and lots of data. And if I supply all the data to the LLM and say, okay, go through all these documents and find an answer for this query. Yeah. Let's say I have 10,000 documents, but only maybe 5 of them are financial documents. And my revenue projections are going to be in the, probably on those 5 documents. We probably won't find the answer to this question in, let's say, an HR document, right? So there's no point in sending all the documents to the LLM. It's going to be slower, right? Because the LLM has to read and pass through all the documents. And it's going to be expensive, right? Remember, when we use LLMs, sometimes we pay by tokens. So the more document you send for the LLM to read, the more expensive it's going to be. So we don't want that, right? We only want to send relevant documents that may have the answer, so the LLM can just read through them quickly and give me the answer. Yep. So how do we do that then, right? How do we only send relevant documents? Now, so the example I use is kind of like a library, right? So imagine a student is asked a question. So for example, they say, okay, so find out something about oxygen. So we know it's probably like a chemistry or a physics textbook, right? And if the student goes to a library and the answer is in one of those books, right? There are thousands and thousands of books available. But if they had to read every single book until they find the answer, as you can imagine, it's not very effective, right? So what we want to do is, so the student goes to a librarian and says, hey, I'm trying to find an answer for a chemistry question, right? Now the librarian doesn't know the answer to the question, but she knows where the chemistry section is, right? So she may go to the student and say, all right, why don't you, these are some basic chemistry textbooks, why don't you start with these, right? And then student can read them, right? So instead of reading like thousands of books in the library, maybe the student is now reading only 3 books, right? Basic chemistry book, and the answer is there. So that's how you have to think about, right? So what the process is, right? We are minimizing the search space. So we are not trying to search through the entire document set. We only want to search through a few documents that actually have the answer. That's it, right? And this is where vector database comes in, right? And that's why we had Stefan, right, give you a bit of a view of the vector database, right? So what the vector database does, just like any database, right? They store content. The content can be documents, right? Audio, video, right? What have you. And they have them indexed. And when we ask a question, they can actually do the search and actually give me the documents that are relevant, right? And right. So this is what we call semantic search, meaning they can actually search by meaning, not just keyword matching. So they can search by meaning, right? So imagine what happens. So I have a bunch of documents, say 10,000 documents. I had them indexed into a database, a vector database, right? Say Milvus. Then we ask a question and say, okay, what documents will have the answer? So Milvus will understand the question, will search through, and out of the 10,000, let's say it's giving me 5. And those are the 5 documents we send to the LLM. Now, sometimes people ask, why do we need LLM at this place, right? Because Milvus already gave me the documents. So the way you have to think about this, so imagine using Google search, right? Remember, the early version of Google search, you ask a question, you get a bunch of links. These are relevant links, right? And then you have to click and go and read through the link to find your answer. Same thing, right? So Milvus is giving you sort of the top few matches. One of them might have the answer. So Milvus doesn't know that, right? It's just giving you top matches, and the LLM will have to read these documents and then figure out the answer. So just like I do a Google search, I get a bunch of links. I don't have the answer. I have to go through each link, and then hopefully one of the links will have the answer. Does that kind of make sense? Yeah. And right, yeah. So that's where the vector database comes in, because it kind of cuts down the amount of documents we have to search through. And now, just an update. Just since I mentioned Google search, now if you go Google search, right, they will actually give you the answer, right? So for example, we do a search for how do I how do we make something, right? Like, how do we bake a potato, right? For example, before they would just give you a bunch of links, and then you had to kind of go click on the link and then figure out, okay, right, what's the temperature you had to set the oven, etc. But now if you say, how do we bake a potato, right, the AI, Google AI will actually give you the answer right there. It'll say, set the oven to whatever, 450 degrees and bake the potato for 10 minutes or something, right? So even the search results are now evolving into AI. You actually get the answer, so you don't have to go through and read the documents on your own. Okay, so back to this. So let me take a quick pause here. Does it make sense, the overall architecture? This is basically what we do in RAG. Yeah.
By the way, Sujee, we do have a couple questions.
Yeah. Let me look at them. Yeah.
Yeah. There's some raised hands too, although, quite frankly, worried about
Yeah. So guys, yeah, if your questions,
speak.
yeah, let's do this. Let's do questions on the chat, please, for now, until we sort of figure this out. Let's see. Right. Oh, question was how scalable are these databases? So remember Stefan said these vector databases are very scalable, right? They know Stefan was saying, was it billions or tens of billions of documents or something like that, right? So yeah, so they can search through documents very effectively. And the technique they use is called embeddings. So that's a little beyond this talk, but basically if you look up the word embeddings, you will actually see how they're actually able to do this. So right, so they are doing more than keyword search. It's what we call semantic search. Yeah. So all right, I'll also continue, but I will also keep an eye on the questions, and I will answer them as we go along. Right. So feel free to post your questions, and if you don't get to all the questions, what we usually do is like we collect all the questions, and we'll put the answers and send you the links. Right. So yeah. So don't worry, put your questions in. So now, so let's go to RAG. So we all understand, sort of the structure, the documents, vector database, LLM, right? So we sort of expand this a little bit, right? So let's say I have a bunch of data. Before the data ends up into the vector database, we had to kind of clean up, process it, right? Split it into chunks, things like this. And this top part is basically done, is what we call data processing or data preparation. And for that, we are going to use a toolkit called DataPrepKit. And in the last Alliance Office server, we went through DataPrepKit. I'll put a link to this one here. But this is the basic process, right? So we have a bunch of documents. We clean them up, put them into a vector database. And once they're in the vector database, then it's pretty straightforward, right? We ask a question, right? And we get relevant documents from vector database. And those are sent to the LLM. And the LLM will pass through the documents and give us the answer. That's it, right? So on a very concept level, RAG is pretty straightforward. Yeah. So yeah, so we'll talk about all the intermediate steps in a second. Yeah, I'll explain this to you guys. So let's talk about the first part of the RAG, which is preparing your data. Because we cannot just take our documents and send it to in a database, because we probably can, but our results are not going to be that great. We actually want to prepare our data, right? Process them, clean them up, and then insert the clean data into vector database, so you get much better results. So we see this stage, like we are going to use a tool called DataPrepKit. I'll explain the code. If you need more details of DataPrepKit, we will link to our previous presentation we did in the last section, last week. Yeah. So again, very quickly, DataPrepKit is a toolkit that has a lot of these common features built in. For example, let's say you want to extract text from, say, PDF documents or Word documents. There's a module for that. Maybe I have some duplicate documents. I want to kind of remove duplicates. There's a module for that. I want to split documents into chunks. Right? I'll explain what chunks are in a second. There's a module for that. So think about DataPrepKit as like a little Swiss Army knife, right? You take on your camping trip. It has all these modules built in, so you don't have to implement them from scratch. It's an open source library. It's a Python library, and it can handle both documents and code. Very powerful. And actually, we'll be doing a series of workshops, in DataPrepKit. So please sign up into Meetup, so you get future notifications. Yeah. And this is another set of features just to kind of more you can see like duplication, identifying programming languages, right? Document chunking, all the features are built in. So and yeah, so again, we will post the link to the all the resources after the session. So don't worry, you will get an email. Yeah. So what I'd like to do, I'm going to walk you through the RAG process, but I also like you to follow along. So maybe take a picture of this or note the URL on this. Now leave this up for a minute. And in the meantime, let me also look at the questions. Question was, does DataPrepKit handle multimodal multimedia? Not yet, but work in progress. Right? That's all I'm going to say right now. so right now it can handle documents and code, multimodal, hopefully coming soon. Yeah. There's a couple of questions about chunking. I will answer them in the next few slides. Yeah. And yeah, so actually, let me post a link to this here. So this way, you just have a link. Hold on. Yeah, so this is the link. If you click on this link here, it should take you to a GitHub page. Yeah. And again, you can take a picture of this. Right now, look at this URL. This page is what we have for this this meetup. And if you scroll down a bit, you will have links to all of our slides, right? So here's a presentation from me. I'm going to update the presentation from Stefan right in a few minutes, and the code. So everything we need is right here. So maybe take a picture of this, or mention, keep the URL. So this is the link for this meetup, right? Everything, we'll post all the resources here. Yeah, very good, guys. So, all right, let me go back here. Are we still presenting? Okay, good. And so if you look at the steps, the first step is, remember, we need to extract. I'll use PDFs as an example, right? We're going to extract some text from PDF. And let me show you how this is done. So for example, let's say I have PDF. DataPrepKit has a module to extract the data into, say, Markdown. So Markdown, as we know, is plain text, right? Is much more parsable than PDF. So what I want to do is I want to extract the content of PDF documents or Word documents, what have you, into simple text, but Markdown. The reason we prefer Markdown is it still has, it can still keep headings, like bullet points, right? So it still keeps a structure. So it's not like plain text. So it's text plus, right? So text and some formatting, but still text. So we are converting into Markdown format. Yeah. And while doing this, it also removes markups, like, for example, if you're emojis or colors and things like this, most likely we may not need those. So you can also remove the markup as it's passing there, extracting the content, which is what we want. Yeah. So let me show you where this is. Actually, let me get you started with the code before I go too much further. So if you just go here, right, this is the link we posted. Scroll down a bit. Here's the code for what I'm showing you. So right, this is in GitHub. So you can go here. The project is open source and it's a very active project. So you see all the issues being open, all the commits coming in. Right, it's a very active project. And if you have any questions, we do have a place for you to ask questions. It's called a discussion forum. So you click on this. It's on GitHub. So you can post questions, right? Because we do want to make sure, right, when you are using this, you are supported. So we don't want to just throw something at you and go away. We actually are going to be supporting you. So if you have any questions or feedback, please use the discussion forum. Yeah. All right. And oh, by the way, yeah. So the link to this, yeah. So let me put this link one more time. Yeah. So, like I said, if you come here, we have links to, we will link to everything from here. All right. So, so scrolling down. So this agenda Milvus presentation. So I will link to Stefan's presentation as soon as I get it from him, right? Maybe in a couple of hours. So check back. And here's the presentation I was talking about, the DataPrepKit intro, right? If you guys are interested, you can look at this and see the presentation. So this gives you a little overview of the DataPrepKit. Since we went through this last time, I'm not going to go through this this time, but you can take a look at it, right? I'm going to focus on RAG pipeline, and the presentation is here. Yeah, and again, the code also here, right? So let me show you the code real quick. So you can click on this, right? And then, yeah, I don't want to have too many tabs open. So if you look at the DataPrepKit examples we are showing, again, how did I get here? From here, right? This is the link. Yeah, and so if you look at this, it's on GitHub. Examples notebook, RAG PDF1, right? So scrolling down, I'm just going to follow this README file. So you can also follow this along with me. Yeah. So same RAG workflow as we outlined. So we are going to start with, first of all, preparing documents. And that basically is done at step 2. So can you look at this code, right? It's very simple. I'm going to walk you through the code right here. Right click. So I'm going to say right click, open a new tab. Oh, by the way, to run this, people ask me how to run this code. Good question. Please do step 1. You have to set up a local Python environment. Typically, I try to use Google Colab for my demos, but in this case, it's a little tricky because remember there are multiple components involved, right? We have DataPrepKit, Milvus, and LLMs, so it's best to run this on your local environment. So, and then this step 1 will guide you how to set it up. So don't worry about setting it up right now. You can follow along the code right here on my screen, and then if you want to try it out, you can set it up. Yeah, good question. Yeah, thanks for asking. Okay. So let's talk about this step. How do you process documents into a format so we can actually save them to a vector database? So, right, and the code is right here. And again, I'll walk you through the code very quickly because you can run this code on your own. By the way, we are downloading a few PDFs from, I'm downloading a couple of papers from arXiv. One of them is attention, right? So this is one of the seminal papers. Remember, attention is all you need. It's the same paper. And then I'm downloading a paper called Granite. This is the IBM Granite LLM model, right? And if you notice, we are downloading it twice. Yep, that's on purpose. Yeah, right. It's not a typo. It's not a bug. I'm getting duplicate content just so I can show you how you can eliminate duplicates, right? So we have 3 papers. Right, one of them is duplicate. And I'm going to walk you through how we remove duplicates. Yeah. So next step, we are basically setting up input-output directories. Remember, right? It's like a workflow. So the step 1, it takes extract documents, it produces some output, then that output becomes the input to the next stage, and so on and so forth, right? So you can only imagine this as a pipeline. So each stage producing, consuming some input, producing output, and then that output then becomes input to the next stage, and so on. Yep. So that's why we are setting up a bunch of directories, and you can see the order, right? I'm extracting. Okay. So scrolling down, let me actually make this a little full screen and make it a little larger so you can easy to see. Yeah, hopefully that's better. Yeah. So we have a module basically that extracts PDF data, and then we are going to use that. So it's very simple, right? Basically 1 line of code, right? I split them into 5 lines just for clarity. Very simple, right? You're saying, read data from here, produce output here. I am only interested in PDFs, and I'm extracting text into Markdown format. Yeah, as we saw. Yep. So, and that's it, right? Run this. By the way, if you're running this, you will notice it also downloads models if you're running this on your locally, because we use a deep learning model to parse PDFs. So it's pretty accurate. It's trained on lots of PDF data, so it knows how to parse PDF files. So when you run it for the first time, it will download the model automatically and then execute it locally, right? So yeah, so if you see a bunch of downloads going on, that's what's happening. We are downloading the model for the first time. That's it. Yeah. And step 3.2, excuse me. If I look at the, what's the output produced, is basically, you can see I'm putting on a table format, so easy to read. So here are my files, right? I had, right? So each file will have one row in the table, and see if you see, look at the contents column, you see actually the contents extracted, and you can see, right? It's a Markdown format already, plain text format, metadata, right? How many pages, how many tables. By the way, this extraction can handle table data, right? If your data is in table, it will extract them very well. It can even do OCR, like if you have handwritten text, it can also try its best to parse handwritten text, yeah, which is pretty great. All right, and then it's calculating a document hash. So you probably already noticed, right? These 2 hashes are the same. You see this, right? Because they're duplicate documents, and we're going to use this to eliminate duplicates. Yeah. So that's it. So PDFs are parsed. Yeah. All right. Next, we are going to eliminate duplicate documents. Let me explain what this entails, kind of concept-wise, and I will show you the code. So let me go back to the presentation here. I have a bunch of documents here, right? So these are exact duplicates, right? I'm just, here's an example, exact duplicate documents. So how do we do this? We have a module that's, dedupe. So it basically is a very simple comparison. They calculate the hash of these documents and compare them, and then eliminate one of the documents. Pretty good, right? So you see, I have two A's, then one A is gone. Yeah. So it's called duplicate removal, and we are going to do this in our code as well. So let me show you. So in our code, wait a second. Let me close all this. If you look at the code, step 4, right? So we have a module called, eDedupe stands for exact dedupe. So we are eliminating exact, basically identical documents. Same thing, right? Input folder, output folder, pretty self-explanatory. I'm asking you to look at the contents column. Remember the contents column we had? We are going to zero in on the contents column. Because if the contents are identical, then they're duplicate, right? And I'm also telling it, saying, okay, use the hash, right? So again, we're going to compute the hash, and then if the hash is the same, they eliminate it, right? One of them will be eliminated. So run this, right? And then when you look at the output, right? Again, I'm printing out on in a table format. You see, before my dedupe, I had 3 documents. Remember, there was 1 duplicate. After, I have 2. Pretty good, right? So what is it? Granite 2.pdf is eliminated, which is good. So I kept the data set pretty small just so we can track the progress. Now imagine you have tens of thousands of documents, and I'm pretty sure there are some of the duplicates. Yeah, really, you can see, right? Just takes 2 lines of code to eliminate duplicates. Pretty good. Yeah? Okay. So next step, I'm going to talk about chunking. So let me show you what chunking works. By the way, when removing duplicates, the one I showed you is called exact duplicate, meaning these are identical documents. We also have another module that's called fuzzy duplicate, fuzzy dedupe, which is actually pretty cool. So look at these two documents here. Yeah. So I'm actually here. So B and B dash, they are almost the same, except like 1 word or something, right? So you may have documents that are pretty like 99.99 identical, maybe like 1 or 2 words different. And let's say for our purposes, it's the same. We have a module can actually go through and remove these as well. So I will have a sample code on I did the demo of this in the last session, so we will link to that. But yeah, so even if your documents like only slightly different, but mostly identical, we have a fuzzy dedupe module that can remove this. Pretty cool, right? So yeah, so check it out. I'll link to this in our session, after session. So next step, we want to talk about chunking. So chunking is basically splitting large documents into smaller manageable sizes. So imagine I have like a 100-page PDF. When I'm answering a query, my answer is not going to be in all 100 pages, right? It's maybe in maybe 1 or 2 pages, or maybe 1 or 2 paragraphs. So we actually want to extract the data into smaller chunks so we can search more effectively. So you see, right, my document is here, and these are chunks. When we do chunking here, right now we are using natural boundaries. So for example, let me show you. For example, you can see this paragraph is becoming 1 chunk, right? This paragraph is another chunk, right? And then this bullet point section is another chunk, right? So kind of natural text boundaries. You can control the behavior here, right? And I believe there was a question about, can we set the chunking size and everything? Yes, you can. Yeah. So because a lot of the time people ask me, what is the right chunking? Should I chunk by paragraph? Should I chunk page by page? Should I chunk fixed 10 words, 20 words at a time? So here's the thing, there's no right answer. You should try a few chunking mechanisms and see which one works for your documents. Right? So there are, if you online, there are a lot of guides, right? People have done a lot of experiments. You should read those. But honestly, at the end of the day, the best chunking mechanism is what works for you, right? Yeah. So, all right, let me show you the chunking code here. Step 5. Again, we have a module. Now, doc chunk, you can see it's pretty straightforward. Again, same thing, input output directory. So it's reading the previous output, right? So I'm asking you to chunk using Markdown. right? Because since we have our documents extracted in Markdown format, I'm saying use Markdown chunker, and then here are the sizes, right? These are the default sizes. I'm just using them, because they are working for me. But you can play around with this. Yeah. So that's like one line of code, right? Run. And what happens is, so let me show you the output, right? Remember, I had two input files. Remember, attention.pdf and granite.pdf. I had two input files. They were split into 60 chunks. Right, so remember, it's going to maybe going through paragraphs and bullet points. Right? We are doing natural chunking. So split them into 60 chunks. And you can print them out if you like, for example, right? So here, I'm just putting out a sample. Let's look at the chunks, right? So these are the contents. You can kind of see, right? These are each sections, right? Becoming a chunk. Pretty good, right? So again, like I said, just one line of code, all it takes. Yeah. So, all right. Once we are done with chunking, next step, what we want to do is convert them into embeddings, right? Stefan talked about this when talking about Milvus, because embeddings are vector representations, basically a bunch of numbers, right?
Hey, Sujee, before you go on, I do have a couple questions I just wanted to highlight here for you.
Okay.
One, the question was, how does this this is by Ravi Singh, how does this handle when the PDF is updated or removed?
Good question. So if your input data changes, right, you need to reindex them. So basically, let's say your document set is growing, right? You start with 1,000 documents, and next month you have, say 1,100 documents. Those new 100 documents need to be indexed. So your index is basically growing, just think like a database. You'll be indexing them, updating your index. And if you remove documents, same thing, right? You'll have to remove the documents from your index. Yeah, so this is something you need to do as part of your pipeline. So your index is continuously updated and evolving. Yeah, great question.
Yeah, and one other question. Can it manage to pull the documents from multiple sources?
So I believe when you say sources, you mean like different locations. Yeah, so right now we support local directories, or if you have data on cloud storage like S3, right, or the S3 buckets, we can pull that too. Yeah, so you can specify multiple locations, and it'll pull the data. So especially when you're dealing at large scale, you're not going to probably have it on your local laptop, right? You probably store the document in S3, and we support S3. Yep. So yeah.
Yeah, and I want to add to that we are always looking for adding new sources and abilities to pull in data. For example, this morning we were just talking about adding the ability to pull down data from Hugging Face.
Yep.
And then make your changes. So pull from a public data set, make your changes, and push it back to Hugging Face if you want. The other thing I want to mention before we go on here is that this is one reason why a vector database is such a good option, because if you create a model or fine-tune an existing model with this data, it is difficult to remove data from a model. But with the vector database, you can simply identify, oh, this data came from this particular PDF file. We are no longer sharing that PDF file. Let's go ahead and remove those embeddings.
That's true. Yeah, that's a very good point, right? So I think, right, it's very hard to remove knowledge from a model, but it's much easier to remove from a vector database. Yep, very good point.
Yeah.
Yep.
Now we have another question here. Let me find it real quick. Sorry, hold on. Oh, can it use protected documents?
Oh, interesting. Okay, so this is a good question. Let me find out the answer for this. So when I say protected, maybe your document like a password or something. Yeah, interesting. So yeah, let me find out how it works with those, and we'll post the answer as part of our follow-up. Great question.
That's a really good question. It should, but that would obviously need to be programmed into it. But that is not. That shouldn't be terribly difficult. But I think it depends maybe how the data is protected.
So like a password. Like a password PDF. Actually, that's a great question. Let me find out. Yep, great question. See. I
well,
love
we're
it.
getting a bunch of questions here, so give me. I know we're over time here, but let's just keep going for a couple more minutes. If you
Yeah,
are
so,
able to keep going, Sujee?
Yeah, actually, yeah. So this goes till 10:30, so we have some time, so that's fine.
Oh, okay, great.
So today we have, since we had a workshop, we are a little longer. So guys, so we are going to be going till for another 30 minutes or so. But if you need to drop off, because the meetup is set for 1.5 hours. But if you need to drop off or whatever, don't worry. We will send you the recordings, right?
Yeah.
So
yeah. And so another question is, can it reindex? It says reindex can change the fine tuning. So that's a question. So reindex can change the fine tuning.
Yeah, actually, good question. So when we reindex here, I will explain. That's a good question. We don't need to fine tune again, because in the RAG example, remember, every question goes with the context. So when you reindex, next time you ask the same question, you're giving different set of documents, right? So there's no fine tuning involved. Basically, like, remember, it's almost like stateless, right? Think like, like every query you're asking, you're also sending the relevant documents to the LLM. So let's say you went through a reindexing, maybe you remove some documents, you added some documents. Next time somebody asks a question, the new set of documents will be sent to the LLM. Yeah, so there's no like there's no extra step. Once you update your vector database, that's it. Yep, that's a good question. I will explain the process next.
And another question here is there any benchmark on the number of files it can handle?
Oh, good question, actually. So that's a great question too. So the DataPrepKit is used, okay, so stepping back. So IBM has an open source LLM called Granite, right? The data used to train Granite LLM, which is, easily terabytes of data, it's actually prepared using DataPrepKit. So this actually is proven at scale. I think I'm forgetting the numbers, but it's most like terabytes of data. They ran on a cluster of like hundreds of machines across, right, to handle the load. So yeah, so it's a very scalable platform. So this is not some toy project, right? This is actually proven in the field, and now it's open source. If you have some questions about scale, please post on our forum, and we will give you some numbers. Yeah, that's a great question.
I'm getting lots of questions here, but I think
let's kind of move on,
here.
and then and then we'll come back, we'll circle back, right? Because I don't want to get So thank you guys. So again, don't worry if I didn't get to your questions. We will save them. Maybe you can sort of like copy paste them into a document. We will go through them and send you a follow up with answers, right?
That's
so
right.
Thank you. Yeah. So let me zip through the real quick, and then we'll come back to questions. Right. So the final step here, right, in our process, again, kind of going back to our pipeline. So what's our final process? So we basically went through extracting text, removing duplicates, we split them into chunks. Step 4 is vectorizing or creating embeddings, right? This is the final step in our preparation. So now that everything is cleaned up, we split them into chunks. We're going to split them into, we're going to create embeddings. Yeah. So that's how it is done. So here we go. All right. Yeah. Right. So chunks are created. And what we are doing is, embeddings, right? Embeddings are created. And we have a module for this. Again, very simple. Let me show you where that is. That's the final step, right? Step 6. And we have a text encoder. And one thing you will notice is we are using an open source model. I think I'm using one of the, by the way, it's actually defined here. Let me actually open this. All the modules are defined right here. So in the config file, what am I using? Yeah, I'm using sentence transformer mini LM, right? This is a pretty small model, pretty small embedding model, but it's pretty, pretty decent data. And you can pretty much plug in anything, any open source model you want here. Yeah. So, and that's it. And then you plug it in, and then, and we will execute it, right? Yeah. And once this is done, if you look at the final output, you will see, right? Again, I'm putting on a table format. So you look at these. Remember, these are different chunks, right? So you see the chunk data, and also embeddings are created, right? So every chunk is now vectorized. And basically, this is what we are going to save to Milvus. That's it, right? So the whole data prep step is now done. So I'm going to basically, next step, I'm going to save it to Milvus. Yeah. So that seems like a lot of steps, but remember, it's a single notebook. So we have there for you, and I just walk you through. By the way, just so everyone following along, right? I'm actually following the steps. So we just did step 2, right? That's basically handles the data. Step 3, we're going to load into Milvus. Let me show you how that is, and that's why we had a Milvus introduction. Very simple. All right, let me show this code here. Right, I am loading. It's basically this step right here. I'm loading the data. I'll show you here. Right. So again, pretty much like a few lines of code, right? I'm saving. Remember we have 60 chunks. All the chunks are now imported into Milvus, right? So you sort of see here, data imported. Very good. And there we go. Oops. Yeah, there we go. Right. So we connected with Milvus. By the way, we are using a local instance of, right, just like an embedded database. So this is why Milvus is great, because you can just start on your laptop. You don't have to set up a database or anything. You can just give it a file, just like SQLite. Remember, if you use SQLite, just everything's in a single file. Same thing, right? So Milvus can actually work at a file level. And once you're ready to go to production, then you will move to a cloud instance. Yeah, very simple. And that's it, right? Insert data, and then insert a 60 rows. That's it. Yeah. So my data is actually in Milvus. Next step, we are going to check the data. And the way we do that is by performing a vector search. And let me show you here. So this is right. So now the data is in Milvus. We are going to actually do a vector search. So what I'm asking a question saying, right? My question is, what is the training data we use for Granite? So Milvus is going through and searching through all the index, and it's coming back, and I'm printing out the top 5 results. You can see the results actually sorted by search score, and this score is basically a number from 0 to 1, close to 1 being sort of the perfect match, right? So we want this to be as close to 1 as possible. So I'm getting like 55% match, not bad, right? And these are the chunks Milvus is returning, saying, hey, these actually have the answer, right? So again, looking at this diagram, right? I'm querying Milvus. Is giving me relevant documents. So imagine I have 10,000 documents here. Maybe it's giving me back 5. Now remember, it's not giving you the answer just yet, right? It's only giving you the documents that may have the answer, right? So all it's doing is it's cutting down stuff you don't need. Like for example, if I'm asking a financial question, it's not going to give me HR documents, right? Because the answer is not going to be found. It's going to give me financial documents, and that's what we are doing. So how do we query this? Let me show you the query real quick. Yeah. And there you go. So vector search. There you go. So again, very simple. Let me show you the real question here. Right? What's the trainer I use for Granite model? So you can see it's printing out a bunch of data, right? Again, these are the chunks we extracted, and it says, hey, you know what? Answer may be found in these segments of data, and that's it, right? So you can see, right, some of the answers I'm printing out, so you can sort of see. So you can see result 1, right? Score, 55. Result 2, sort of a little less, and so on and so on. Remember, they are ordered by the results in the search score matching, right? And remember, they're all coming from Granite PDF. Very good. That's what we want, right? Because the question is about Granite. It's not going to find the answer in the attention.pdf, right? So it's only extracting documents from the chunk from the Granite file and giving it back to you. Yep. Anyway, so we have the documents. So I'm like, you know what? Yeah, seems good, right? So I'm getting relevant data. That's very good. Yeah, that's it. So this is like a quick check to see if you can actually, right, find what you're looking for. All right, final step. We're almost there. So final step is combining all this and send this data to LLM. So remember, right, when I'm asking the question, Milvus vector database is giving me relevant documents, but not the answer. To find the answer, we are going to send those documents to the LLM. So LLM is going to read through the documents and look at my question and then give me an answer. So let me show you the final step here. I am using a replicate service to call to invoke LLMs. Most of you probably will end up using an API service because it's much easier to use rather than hosting your own LLM, which you can, right? I mean, but remember, a lot of the LLMs are pretty heavyweight. If you want to run this locally, you probably need a GPU to get any reasonable performance. So a lot of the time, we actually recommend starting with an API service, right? Like even if you're using like OpenAI, you are using an API. But Replicate actually hosts, like if you go to the Replicate website, right? So, right, you can pretty much run any model with any API. And if you look at their models, right, go to the Explore tab, I'd see that, right, they have a lot of the models, proprietary and open source models available. They even have DeepSeek. Run this. So there are a lot of models they host. So all you have to simply say is like, if you say, yeah, run this model, with this data. That's it. Very simple, right? And here I'm showing you some of the open source models I've tested with. So you see Granite, right? This IBM and also Llama from Meta, right? These are all available. They even have this massive model, the 400 billion Llama model, right? You can just run it. Of course, remember, right? When you run this, you are paying for usage. So if you run bigger models, you're going to pay more, right? That's how the math works. By the way, if you're signing for Replicate in our in our documents, we actually have like a little code. If you add this code, it'll add some credit to your account. I think it's like $1 or something. Don't worry, right? Remember, $1 will give you like 1 million or so tokens, right? So that's good for a few, maybe tens of queries. So that's all you need. You don't need to set up your credit card. Just use our code to add some credit to your account, and then you can use it. All right. So let me show you how this is done. All right. So I'm asking the question. My question is like, what's the training data for the Granite? Yeah. So it goes through. See, then I get the answer, right? It says, yeah, Granite model trained on these data sets. So what's happening? Remember, right? So remember the workflow. So the query first hits the vector database. We get 11 documents. They are sent to LLM. And LLM reads through the answers and give. Because if you remember, right, my results from if I just did a simple vector search, I get a bunch of documents. They are relevant, but I still have to read through them and find my answer. Think like Google search, right? Google search, when you do a search, you get a bunch of links. You still have to click through, go through each link and find your answer. Same thing, right? So if you just do vector search, you will get relevant results, but not the answer. Answer you still have to find out. And that's why we are using LLM to do the next step. So let me show you step 5. So we're using Replicate again, right? So you can follow through this to set up the service. Let me show you the code real quick. And basically what we are doing, this is the last step. So again, what we are doing is, right, in Replicate, right? If you sort of scroll down a bit. There we go, right? Step 6 is where we are specifying the LLM. So you can see, right? My model, what model am I using? So let me look at this config page. There we go. I'm using Granite 3.B, yeah, 8 billion model. And this is a pretty decent model. It works pretty well. So you can use it, right? So that's what we are specifying. And that's it. All I have to say is, specify the model and ask me questions. That's it. Yeah. So there you go. And here we are setting up some, again, like step 9, you will set up, questions like, system prompt, user prompt, basically, right? So I'm saying, use the context to answer questions, because I want to limit the answers to the context I'm providing, right? Because I don't want the model to kind of freelance and come up with answers. We want to confine the answers to the documents we are supplying, or the context, right? So you can see the context is what we are supplying. These are the relevant documents. And then I'm asking the question. The system prompt is basically, you're an AI assistant, right? You're going to answer questions. So the system prompt sets the tone or the role of the LLM. So the LLM says, yep, okay, I'm going to read a bunch of questions and answer, right? And then we are supplying the context and asking the question. Is that going to make sense, guys, right? So remember, this is what I said, RAG is very, every time you ask a question, right, you are sending a context. There was a question about, what happens if my data changed? No problem, right? Next time you ask the question, your new data will be sent into context. Yeah. So yeah, so there's no need to retrain or fine tune anything. RAG is basically stateless, right? Every question also carries a context with it. Yeah. So, all right. So let's do the question. Right. Again, I ask the question: what's the training data for Granite model? And you see the answer. Pretty good. All right. So we've been through like maybe 4 or 5 documents we sent. It read through them all and summarized the answer for me. Pretty good. Next question: what is the attention mechanism? Right. Again, the answer. Right. This is what a lot of the transformer models are built on. And then final question, I'm kind of playing this a little bit. So I'm asking, when is moon landing? And I always do this when I do RAG. This is to test if the model is actually confining its answers to the documents I supplied. Now remember, this is public knowledge, right? So any decent LLM should know the answer to this. You know, this is public knowledge. It's in Wikipedia and many pages. So they're trained on this. But when I ask the question, it says, sorry, I can't find the answer in the provided context. Right. So that's good. That's what I want, right? I don't want my model to do randomly guess answer, right? It has to confine the answers only from the documents I provided. So and it does that. And I kind of recommend you guys do this too, just to kind of test it, just to see, right, how well your model is confining your answers, and this is a good test. You know? So, and you want to ask a question that is public, right? Meaning like the model knows. You remember, right? Because models are trained on public data, so you want to ask a question that is public, that the model should know. But in this case, you should get a no. Sorry, I cannot find the answer because it's not part of the context. Yeah. Good. All right, guys. So that's pretty much what I want to show you. Let me see. Yep. All right. So that's it. I think we made pretty good time, and we have a few minutes left. So I'm going to go through the questions. Here's a link to our GitHub page. You can take a picture of this, make a note of this. It will basically bring you to this page that has all the links, and then we will also update the links that that like presentations and things like this. Yep. So this is all you guys need at this point. Let me take a picture of this. Let me look at some questions.
Yeah, you can start looking at around 10 o'clock. One question that we didn't answer was right after the benchmarking question. There was another one. Do you have the entire workflow to resource measurement, like say 100 docs per CPU? I don't know if we have that kind of information, but
that's a good question. Let me. I mean, I don't, but let me see if I can find an answer for this. Yeah, that's a good question. Yeah.
Yeah, we'll have to get more of the performance metrics. It's meant to scale, but scale can mean different things to different people. There's another question here. It's in Spanish. It's hard for me to really understand what the question is, but it says, I think it says Milvus and NoSQL categorize. I'm going to try to answer this real quick, since I spent a lot of time in the NoSQL business. So Milvus is a vector database. It is in the NoSQL category. So you don't run SQL queries against it. And it is definitely a vector database, although it does contain other data. You can have metadata and other data in there. But it's not like a document store. It's not a SQL. It's not a graph database. It has its own category. So vector databases are sort of their own category. Although a lot of these databases, NoSQL databases, do have multiple, formats of data that they store, but they're all sort of different. So yeah, it's specifically meant to do vector search.
Mm-hmm. Yep. Oh, by the way,
iWeb Digitals, I don't know who this is, said that Python library available for protected PDF. So it looks like there's at least a Python library out there that might help you pull out data from protected PDF files.
Yeah. On that front, you need to sort of unlock the PDF first, then you can feed it to the into the pipeline, and then we should be able to extract it. Yeah. So,
But the next question I see here is
we'll post some links here. Yeah, we'll post some links here.
The next question I see here is at 10:02 by Shakar.
Yeah, I see
How do
it.
you compare? Okay, yeah. How do you compare this chunking with multi-model embedding that can ingest diagrams and charts?
Good question. So, in this processing space, there are a lot of processes in place. We use something called dockling. So dockling is actually pretty good. Let me actually show you this thing real quick. So dockling can parse pretty good set of documents. So as you can see, I'll put this link here. It's a good question. So this is a model we use. As you can see, they support multiple formats, and also they are pretty smart. They can understand like layouts of the document, right? They can extract data from tables. They can even do OCR. There was OCR, right? So if your PDF has like handwritten text, they can even perform OCR and try to extract some text out of that. So yeah, it's very capable. But like I said, this is not the only game in town. There are a lot of other document processes as well. Use and see which one works for you. But dockling is pretty advanced processor. You can pretty much handle what you throw at it. Right. So if you have any issues, please post in our forum. We will try to answer them for you. Yeah.
And then another question here is, does Milvus equal MongoDB? Again, no, they're different. MongoDB is definitely more of a document model. MongoDB does support, I used to work with MongoDB, I know these answers. MongoDB does have a vector database capability, and it is pretty good. But there is a difference between an open source project like Milvus, which is really hyper focused on vector search, vector capabilities, and is tuned specifically for large scale. And MongoDB, which I think for most use cases, MongoDB is probably just fine, but it is not going to have the same type of capabilities like a Milvus at the high end. It's just not. It's like, like a Honda versus a Ferrari or something. They're just different.
Right. Yeah. And let me go through some of the questions. So thank you for the iWeb Digital. You posted the PDF example, code example. That's great. Thank you. Oh, another question is, when I convert PDF from Markdown, I'm losing some metadata. True. So one thing I will say is right. So in this example, I use PDF to Markdown conversion because that's the simplest. You can also extract PDF in JSON format. So the JSON format will retain more metadata. So things like page numbers and things like this. So for example, if you have a key use case, you want to extract PDF, but then you want to sort of process some metadata-based processing, like maybe page numbers, headings, things like this. Yeah. So what you can do is you can specify the output format to be JSON, and then you have pretty good control over what you want to process. Yeah, good question. Yeah, very good, very good. By the way, these are, again, we'll post all these links here. So the presentation I was looking at was DataPrepKit intro. Right, that walks you through some of the features the kit has. So today I focus mostly on, so today we did section 1, Milvus introduction, and RAG pipeline, right? So the last session we did DataPrepKit. So please take a look at the presentation if you're curious. All right, let me zip through real quick. Yes, we do support multiple document types. Since we use dockling, pretty much anything dockling supports, we support, right? PDF, Word documents, HTML. Yeah, so it's very versatile. Question from Andre. How do you test RAG produces actual relevant answers? This is a very good question and also kind of a loaded question. There are a lot of benchmarks, a lot of test suites or benchmarks available to test your RAG model performance. I didn't go into them here, but there are a lot of open source benchmarks you can say. So some of them can be automatic. Some of them you can add your own answers. And when the model produces answers, it'll compare them and then give you a score. It's like 80% accurate, 90% accurate, right? So yeah, take a look at those. If you do a search for RAG benchmarking or RAG evaluators, you will find a bunch of open source projects. You can adapt one of those. Yeah, good question. Yeah. So let me see. So I'm not familiar with the Vectrix. I don't know, Dave, if you might be. Is that another database? I'm not sure. I'm not personally familiar with it.
No, I don't know it very well.
Yeah. Reindexing. Let's talk about reindexing. So in a this step, remember, unless your document set is changing, like new documents coming in, removing old documents, or some documents getting updated, things like this, that's when you would do reindexing. And in a typical enterprise, you probably will do this on a pretty frequent basis, just so you got the latest documents. And this step can be expensive depending on how many documents you have. For example, whether you have a few thousand or like a few million documents, that's going to determine how much effort it takes to do reindexing. Yeah. So honestly, it depends on your amount of data. So maybe you have lots of documents, but small documents, maybe 1 or 2 or 3 page documents, or maybe your documents are like very massive, like 1,000, 2,000 pages. They will take more time. Yeah. So good question, but yeah, basically we'll reindex whenever our documents changes, right? Because we want to make sure the index is up to date. Because remember, when we ask queries, that's where the context is going from. So we want to make sure this vector database has latest index. All right, guys, a couple more questions. I think we have 2 more minutes. Right, I like this one. I will take this one on. So which LLM gave you good answers? That's really good. I'll take this on. So I tested with mostly open source ones because remember, we are big proponents of open source in AI Alliance. So every toolkit I mentioned today is open source. Replicate, of course, is is a service you have to pay for, but we give you credits. Credits you can have, user credits to have a few API calls. So I tested with these Llama. So you want the model to be a decent size. Like to me, 8 billion is a good size without having I don't have to go to like a 400 billion model, right? That's kind of an overkill. So to me, like a 8 billion around there gave me pretty decent results. I used both Llama and Granite. Granite, I would say maybe the 8 billion is slightly better than the 2 billion model, just because remember, right, larger models have, they have a little bit more smart. But yeah, I'll start there. Easy to experiment because remember, right, when I do the, let me show you the code here. When you set up an LLM, it's very straightforward to specify, specify your model. Yeah. Oops, there we go. All right. So you can have the same code. You can cycle through different models. Remember, you're calling an API service and kind of look at the answers and say, oh, maybe we like this model. So personally, I had pretty good luck with Llama and then Granite. Yeah, good question. Yeah. I haven't used Gemma 2 yet. Actually, I have used Gemma 2 for other queries locally on my machine. It does pretty well. So yeah, so you can try. Like I said, you can just plug these in and see which one you do. You kind of want to find a model that's small enough, but also big enough. You know what I'm saying, right? You don't want an overly big model because then you're paying too much, and then it takes a longer time. You don't want too small a model that may not be, doesn't have the smarts to understand, documents, complex documents. So you kind of want to find, your sweet spot, and then experiment a few times and see which one gives you good results. Great questions. All right, guys, let me do this. Let me stop here, and I'm going to copy the questions, and we will send you a follow-up with the answers. So this way, right? I'm sorry I didn't get a chance to get to all the questions, but we're out of time, and I don't want to keep you too long. So again, thank you so much. Let me put the link up so you can take a quick picture. So thank you so much for being part of the office hour. We hope to see you in other sessions. Please sign up so you'll get future notifications, and we will see you soon. Yeah, thank you.
Yeah, thank you everyone for joining. Really appreciate that. I know there were a couple last questions here that we didn't get a chance to answer. Like one question, I'm just going to really quick answer is, what size LLM model? By the way, Mark Wolf, LLM, large language model, it's basically the algorithm that the generative AI uses. It's a big giant file with massive amounts of data in it. But yeah, it's the thing that has all the answers basically. And yeah, we'd have to explain more. It'll take longer to explain how the whole thing works. But basically what you're doing is you're using it to answer the question, but to get the actual answers, you use the vector database to get the data that's going to be used for the answer. And then the LLM is the one that actually uses, that creates the human readable language to respond, right? So that's how it turns that vector data into an actual human readable answer. But as far as how big it should go, it really depends. Like you want to use a fairly large model if you want it to be better, and so you might want to have a large GPU with lots of memory, and then you can run a large model. So it kind of depends on what you're trying to do. I know that's not a very good answer. Okay, and we'll try to answer more of these questions in more detail in follow-up. And
we'll post our answers soon.
Yeah, and if you want, like if you have more topics that you'd like us to address, feel free to share them here, and we can try to consider them for future presentations.
Okay. Yep.
Yeah.
And again, thank you all. Thanks for your patience, and then we'll hope to see you soon. Thank you.
Yep. All right. Thanks, everyone. Thank you, Sujee. Bye-bye.